Hey guys, what's happening? So today we're going to use those properties that we were working with last time, the properties of logarithms, and we're going to be solving equations. So here's what I'm going to do. I'm going to go kind of fast. I'm going to try to do as many examples as possible. I have a lot, and I have to do them in under 15 minutes, or else I have to make 2 videos. Okay, so again, I'm going to go kind of quick, but pause it, rewind it, do whatever you need to. Okay, so here we go. First example, we're going to be solving some equations by equating the exponents, okay? So if you have something like this, 7 to the power of 3x plus 4, and that equals 49 to the power of 2x plus 1, okay? We can solve this by equating exponents. Now, it might not look like it, okay? But let me just give you an example. If I have something like this, okay? Give me a second here. If I have something like this, 5 to the power of x equals 5 to the power of 7. Can you solve for x? It's not a trick question, I swear. Isn't it 5 to this equals 5 to the 7? So isn't x equal to 7? X is equal to 7. So you can solve that by equating the exponents. Okay? So this guy over here is a little different. You can't just say 3x plus 4 equals 2x plus 1 because the 7 and the 49 aren't the same. But I can change that 49, okay, so that I can equate the exponents. Watch this. If I have 7 to the 3x plus 4 equals, isn't this also 7 squared, okay, to the 2x plus 1? All right. 7 squared is 49 to the 2x plus 1. And now watch, just distribute that to the power inside. So we get 7 to the 3x plus 4 is equal to 7 to the 4x plus 2. All right, now I can equate the exponents. 3x plus 4 equals 4x plus 2. Move the 3x over, you get x equals, move the 2 over, you get 2, and we're done. Okay, x equals 2. All right, let's do another one. Here we go. How about 10 to the power of 3x minus 10 equals 1 over 100, okay, to the power of 6x minus 1. We're going to do the exact same thing, okay? All right, so they don't match, do they? Okay, we need them to match though. Okay, now there's a couple different ways we can do this. I can get from 100 to a 10, right, by taking the square root. That's the power of 1/2. I'd also have to flip it, so it's going to be the power of negative 1/2, okay? But I don't know that I want to go that direction, because if I change this to 10 to the power of negative 1/2, I have to distribute that negative 1/2 to this. I'd rather not do this. So watch what I'm going to do. I'm going to take this 10 and try to get it to turn into this right here. Okay? So watch this. This is going to be something to the 3x minus 10. Okay? And actually, you know what? Shoot. You know what? I think I should have done it the other way. I'm sorry, guys. My bad. I'm just making sense of this in my head now. I think I'm just distracted. Okay, so watch this. I have 10 to the 3x minus 10. Watch what I do here really quick. Okay, yeah, I'm sorry. I was distracted. I just wasn't paying attention. Okay, I want in here a 10, don't I? Okay. Okay, but this 10 has to equal this. So what do I need to do, okay, to this 10 to get it to equal that? Well, I need to flip it, right? So it's got to be negative, okay? And then I have to square it, because 10 squared is 100, so this is 10 to the negative 2. All right, sorry about that. I just wasn't paying attention. I was just thinking of other things. All right, so, and if you're not sure, remember you want these numbers to match. Okay, and then ask yourself, what is 10 to the power of negative 2? Well, 10 to the power of negative flips it to 1 over 10. Square it, you get 1 over 100. And then this is still 6x minus 1. All right, and now the bases match. So now I can say 3x minus 10 is equal to negative 12x plus 2. All right. And now just add the 12x, you get 15x equals add the 10, you get 12, and then divide by 15. So x equals 12 over 15, which they're both divisible by 3, so that's going to be 4 over 5. X equals 4/5. Okay? All right. Remember, the main thing to do is you want these bases to match, right? Okay? And I would always go with this smaller number. Like if you have a 49 here, then chances are it's going to be a 7 and a 7. 7 squared is 49. All right, you have a 10 and a 100. I know it's 1 over 100, but think about the 10 versus the 100. Get that smaller number. So 10, put a 10. And then what power do you need to raise that to get to that guy? Okay? All right, so that's part A. Let's do part B. All right, part B is going to be solved by switching to log form, okay? So solve by switching to log form. All right, here's my first example. 8 to the power of x is equal to 25. Okay, so remember, we're trying to solve for x, right? But x is written as the power, okay? We're switching to log forms because logarithms give us the power, okay? So switch to the log form. That means you're going to see log, right? And log base something. What's the base here? The base is 8, so log base 8 of 25 is going to equal our x. And now all you have to do is solve for x, right? Well, this... you can go into your calculator, okay? Clear all this. You could go into the math setting and scroll down until you hit the log base something, okay? But I think we would rather you use change of base, okay? So if you use the change of base, that's going to be the log of 25 divided by the log of 8. That equals x, okay? And now you can put that in your calculator, okay? So... let's see. I wonder if I could do it this way. The log of 25 and then divided by the log of 8. I bet I can. All right. Before I hit enter, let me just think. 8 to what power gives me 25? Okay, well I know 8 squared is 64. So I know it's going to be a number less than 2. So hopefully I get 1 point something. Let's see. Oh yeah, 1.547, 1.548. So x equals 1.548, okay? All right, let's do another one. How about, try this. 7 to the 6x equals 12. All right. And again, switch to log form. So you're going to have a log base something. What's the base? Log base 7 of 12 equals 6x. Okay. All right, do the same thing there. We have the log of 12 over the log of 7. That equals 6x. So put that in your calculator. Okay. So log of 12 divided by log of 7. That equals 1.277. So 1.277, that equals 6x. And now divide by 6, right? Divide by 6. So x is equal to, I'll just divide this by 6. X is equal to 0.2128. 0.2128. Okay, that's how we're going to do those. Okay. All right, let's see. I'm at 9 minutes. All right. Let's do a couple more examples of this. I'm going to have to make 2 videos. All right, so here's another one. 10 to the 3x plus 4 equals 9. Okay, 10 to the 3x plus 4 equals 9. All right, first things first. We're trying to solve for x. Okay, we want to get rid of everything we can. So move that 4 over. So we have 10 to the 3x. Subtract the 4, okay, so equals 5. Okay, switch forms. So log base 10 of 5 equals 3x. Okay, notice I didn't write the 10 there. All right. And now you can just put that in your calculator. Log of 5, okay, and that equals 0.69897. So 0.69897 equals 3x. Now divide by 3. Divide by 3. So I'll go ahead and divide that by 3. And that equals 0.23299. 0.23299. Okay? All right, and let's do one more. Let's just do one more and then I'll stop and start another one. Okay? All right, let's see. How about 5 times e to the x plus 1 equals 10. Okay? Again, move that 1 over. So we have 5 times e to the x equals 9. Okay? Get that e to the x by itself, so divide the 5 over. So e to the x equals 9 over 5. Okay, now switch it to the log form. Okay, so the log base e, right? If it's log base e, what should you write instead? Okay, you should write the natural log. Okay, log base e is the natural log. Okay, the natural log of 9/5 is going to equal x. Okay, and now we can just plug that into our calculator. The natural log is ln, right? So hit ln, and then it's 9/5, so just go ahead and put 9 divided by 5. Hit enter, and you've got it, 0.5878. So 0.5878 is my x. Okay? All right, I'm going to stop here, and I'll start a new video. See ya.